Hello. In this video, we will talk about what is API and event-driven architecture and how are they different from each other. So let's start. First is the API-based architecture, which is called a request response communication, wherein let's take an example of a user who's logging into a website or accessing a website where the user wants to buy a product. Now, as part of the request response architecture or the API architecture, when the user clicks on the buy button, an API is generated towards the payment section, and then once it is done, it moves to the inventory and then the notification. Now, important thing here is this is all tightly coupled and a linear motion. In fact, let's say the inventory service is taking much longer time or it is down. In that case, a rejection would be passed on towards the user and user will not be able to do the complete process of buying the product, which is the challenge. In fact, just look at the scenario where let us say it is a flash sale and there are many users who've popped it. Now again, the same thing, everybody clicks on the buy button at the backend API is working, but still it is getting overwhelming for the system. And again, the end-to-end process of completion of that order is not done, which is a bad customer experience. Now, how to handle this challenge where the user experience needs to be improved and dependency on so many requests need to be addressed. This is where event-driven architecture or the EDA comes into picture. So in this case, we have three roles. One is the publisher, which is the actual front-end side of it. Then a broker, which is in this case Kafka. And then we have the subscribers also who are having respective roles as part of the service chain. Now, in the event-driven architecture, what happens? Same as before, the user clicks on the buy now button. In this case, instead of the API call, an event is created and that is pushed towards the Kafka, the broker, or it can be RabbitMQ also as the broker. Now, this event is pushed into the queue of the Kafka broker, and all the services, inventory, notification, or payment, they are listening whether there is a new event which has come up. And once they look into that, they will immediately start working on their respective work area, which is parallelly happening. So you see here, publisher and subscriber are loosely coupled, unlike the API-based communication where they were tightly packed. Now, in this case, what happens is that let's say we have more users who start popping up and start overwhelming the system. Now, Kafka has a queue. It will not drop those additional packets or events. Rather, it will put them into the queue for the services, that is inventory, notification, and payment, to keep on working at their backend at their own pace. And at the front end, the message to the user would be order has been received. So we are not dropping the message or because of any service which is going down, let us say notification is not working. This does not mean that the order of the customer is not complete. It will be completed and it will be happening at the backend side of it. So this is one advantage. Another is, let us say we have to add another service here. It will be added seamlessly without disrupting the service logic. So these are the advantages what EDA or the event-driven architecture has over the API-based tightly coupled architectures. That is why it has been preferred in many of the scenarios and is the avant-garde approach where architecture in microservices is preferred. So this was all about API, which is a request response type of architecture, and the EDA, that is event-driven architecture. Hope this video was informative. Thank you.